Good day to you out there. You are welcome to my class for today. Today I want to have a look at the subject chemistry. And the topic I'm going to take is volumetric analysis, which is also called titration. Titration is a kind of reaction between an acid and a base to produce salt and water only. But I want to start from the root. Therefore, I'm going to start today with calculating the concentration of solutions in mole per dm cube. When solution is given, the concentration rather of a solution is given in mole per dm cube, it simply means the molar concentration of that solution. Mole per dm cube there means the amount of the solute or the salt that is in moles dissolved in 1000 cm cube or 1 dm cube of the solution. Again, molar concentration in mole per dm cube is simply the amount of the substance in mole that is dissolved in 1 dm cube of that solution. This is going to be in episodes. So this will be my episode 1. So let's go along together. These are the questions I want to treat for today. Let me pause the video while you give it a try. Now, these are the formulae that we shall be using under this topic, volumetric analysis. Molar concentration in mole per dm cube. This is the formula, mass concentration in gram per dm cube divided by molar mass in gram per mole. Number of moles is molar concentration in mole per dm cube multiplied by volume in cm cube or divided by 1000. The reason why we are dividing by 1000 here is to make this dm cube and cm cube here uniform. That means we are converting the cm cube here to dm cube. So, but if the volume is already in dm cube and this one is in dm cube, then we don't need to put 1000. Please take note of that. Then another formula, number of mole is mass given over molar mass. Now, let's go and solve the question we already have on ground. The first question is to find the molar concentration of 14 grams of potassium hydroxide in 1 dm cube solution. Now, 14 grams in 1 dm cube means 40 grams per dm cube. Therefore, that represents the mass concentration of potassium hydroxide. So we are given mass concentration, which is 14 grams per dm cube. But to find the molar concentration now, we need the molar mass. Why? From the formula, one of the formulae that I wrote on the board, that molar concentration is equal to mass concentration over molar mass. So, do not forget, molar concentration is also called molarity. Please take note of that. Molarity. Now, I need to find the molar mass. Molar mass equals to, I'm going to add the relative atomic masses of these elements together. K, which is potassium, is 39. Oxygen is 16. And hydrogen is 1. That will give me what? 56 grams per mole. Alright. The next thing is to bring in this formula. So molar concentration now will be mass concentration, which is this, over 56. And what would that give us? So the answer is 0.25 mole per dm cube. And need I tell you again that the mole per dm cube can also be expressed in molar. That means in some textbook you can say this. That capital M means molar, and it means the same thing as mole per dm cube. Take note of that. This is another question, a bit different from the first one. We are calculating the molar concentration of 3.65 grams of hydrogen chloride, which is HCl, in 250 cm cube of the solution. In 250 cm cube. Remember the first one says in 1 dm cube. And the mass concentration of any standard solution must be in 1 dm cube. Please take note of that. So definitely we have to, if 3.65 grams is in 250 cm cube, there is need for us to find how many grams will be in 1 dm cube. And that, whatever we now get, will be our mass concentration. How do we go about that? We have to recall first that 1 dm cube is equivalent to 1000 cm cube. Please take note of that. That's a conversion factor. Now, let's work the mathematics. 3.65 grams in 250 cm cube. So let's say x gram now, since we don't know, in what? 1000 cm cube. Because 1000 cm cube represents 1 dm cube. By the time you cross multiply, your x will be 1000 times 3.65 all divided by 250. What would that give us? That gives us 14.6 grams per dm cube. And this is the mass concentration of this HCl. This simply means 14.6 grams of HCl will be in 1 dm cube of the solution, or 1000 cm cube of the solution. So the next thing now is to find the molar mass of HCl before we can go on to find molar concentration. So how do we find molar mass? Don't forget, by adding the atomic masses of the component elements. Hydrogen is 1, chlorine is 35.5, and that's 36.5 grams per mole. So having gotten this, we now employ the formula molar concentration equals to mass concentration over molar mass, and that will be 14.6 divided by 36.5. .400 mole per dm cube. That is the value of the molar concentration of hydrogen chloride given.